Now we are in chapter 2, lesson 2.1. It's a very easy lesson. It's not hard at all. Just it's a new concept for you to learn it. It's about functional relationship. It's about relations and function. What does mean relation? What does mean function? And how we're gonna determine if a relation it's a function. First, let's define what does mean relation. And the symbol of relation is R. You see the letter R. What does mean relation? A relation is a set of ordered. So I have a set of order. It means I have two values. The first value, we call it the domain. The domain is the set of all the x values. And also we call it the input. The second value is the range, and it is the set of all the y values, and we call it output. So if I look at those set that I have here, those are ordered. This is the first one, this is the second, this is the third. What is the domain here? The domain, it's just I look at the values of x. 2, 4, and 1 is the values of the domain. What is the range? 3, minus 1, and 7. This is a relation. Now, how a relation becomes a function? First, the function, the symbol of the function is the letter f. A relation is a function if, and it's very important to understand if what? I have two conditions. If those two conditions are verified, so I can say that it's a function. F acts on all elements of the domain. What does it mean? If I want to summarize this sentence or to understand what does it mean, it means all x must be used. All x must be used. It means you need all the time to see if I have in the domain. Sure, it's not all the values of x, all the numbers, but in the domain, if I have some values of x that they are not used, they don't have an image y, it means it's not a function. We will see it in the example. The second one, each x should be assigned to exactly to one y. An x cannot have more than one y. It should have exactly one y. All the time I give a trick to my students. You look at the domain, you look at x. And first you see, I am using all the axes from each x. Do I have an arrow going out? If yes, it means I am using all the axes. And I need to see one arrow going out from this x. I have one road going out. If there is more than one road, it means it's not a function. Let's look at the first example here. I have three figures, three diagrams, and let's see if it's a function, yes or no. All what you need to do is to look at the domain X. And I see I have just in the domain 1, 2, and 3. Am I using all those values? It means each one of them have an arrow going out from it, yes. So the first condition is verified. Exactly one y is assigned to this x. It means from 1, I just have one arrow going out. From 2, yes, one arrow. From 3, one arrows. It means I don't have the same x that has 2y. It means this is a function, yes or no? Yes, this is a function because all the x's are used, and for each x, I have exactly one y. We write it this way. It is a function because all the x's are used, and for each x you have exactly one y. Let's go to the second figure. Is it a function? I look at x. Am I using all the x's? Yes, I'm using all the x's. Excellent. And do we have from each x one arrow going out? Yes. So I'm using all the x's, and for each x you have exactly one y. So the two conditions are verified. So it's a function. Excellent. Let's move to the last one. Is it a function? Am I using all the axes? Yes, one has images and four has images. I just have to. Then, oh, each x has exactly one y? No. Number one doesn't have one y. I can assign to the domain x 2 or 3. It means this is not a function because the second condition is not verified. We said here each x should be assigned exactly to one y. Is one assigned exactly to one y? No, so it's not a function. Let's do another example, but not as a diagram. I can have it as a set of points. Let's see, is part A represent a function? So what should I do? You just look at the x and do you see if you have a common x somewhere. Let's look at A. The domain is what here? If I want to write the domain, guys, the domain is -2, -3, 4, and -1. Look at it, -2, -3, 4. I don't have any x that is repeating. Excellent. And then each x has a y. -2 has 0, -3 has 3, 4 has 2, -1 has 7. Guys, I can have here -2, 0, -3, 0, 4, 0, -1, 0. It's still a function. So yes, this is a function because for each x, I have exactly one y and all the x's are used. If I go to part B, if I want just to write the domains, I have -2, I have -2 again, and I have 3. So is it a function? No, it's not a function because the point, the value x, the domain x has 2 is assigned to more than one y. -2 has an image 1 and 4. So is it a function? No, because x equal to 2 has two images, 1 and 4. So this one, the set here, is not a function, it's just a relation. Also, we can have as a given equation. I can give you an equation and ask you, does this equation represent a function? Let's look at the first one. Is it a function? What is this? It's an equation of what here? Yes, it's an equation of a line. And for each x, I'm going to have exactly one y. If I replace x by any value here, you will have exactly one y for x. So yes, it's a function because for each x, I have exactly one y, and all the x's have an image. All the x's have an image. If I give you, for example, y is equal 4 over 2 minus x, is it a function? Be careful. Over r here. No, it's not, because for x equal to 2, x equal to 2 is not, doesn't have an image. But I can say that it's a function between 0 and 2 union 2 plus infinity. But it's not a function over R, this one, because for x equal to 2. So this one I can write it's a function. It is a function over minus infinity 2 union 2 plus infinity, but it's not a function over R because for x equal to 2, this one doesn't have any image. This one, y squared equal x, is it a function? If I want to solve this one all the time, the best way is to write y is equal. So y is equal plus or minus radical x. So if you replace x by any value, let's say x equal to 2, this one gives me how many y's? It could be y is equal plus radical 2 or minus radical 2. For the same x, I have 2y. Is it a function? No, it's not a function. Because for the same x, I have two images, radical 2 or minus radical 2. For any x, if you replace by 1, 2, for the only one is just 0, it's the same one. 7, any value of x, it gives me 2y. So no, it's not a function. I still have one more example, and this is graphically. How can I know, how can I predict, or how can I determine if it's a function, yes or no? To know if it's a function, graphically, I need to use the vertical line test. And if you draw any vertical line that cuts the function in more than one point, it means it's not a function. So I just use the vertical line test. Look, this vertical line test cut the function in 2 points. What does it mean? It means, for example, if you, let's say this value of -1, x is -1 has two images. Let's say 2 or -2. So for x equal to -1, I have two images. So it means it's not a function. So using, we call it the vertical line test. It must cut the function in one point. The vertical line test must cut the function and, sorry for the handwriting, one point. I'm repeating what I'm writing here. The vertical line test must cut the function in one point. Since this any vertical line test, look at this one. Also, it means if I say this point is 2, for x2 I have y, let's say 3, and I have for another value -3. It means for the same x I have 2y, so this one is not a function. If I look at this one and you draw many vertical lines, it's going to cut the function in exactly one point, the figure, sorry. So it means this is a function. So using the vertical line test, since it cuts the figure in exactly one point, so it represents a function. And now in the question, it was mentioned also, if it's a function, you need to determine the domain and the range. This is what I really, really care about. What does it mean domain and what does it mean the range? Guys, to find the domain, you need to see the values of x are between which two numbers. So for the domain, I just look like this horizontally. The function starts from which point here? From -3. Is it included or excluded? When it's like this, it means included. If it was open like this, it means excluded. So I did it like this on purpose. So x, I'm moving like this. What are the values of x? It starts at -3, and where the values of x ends. When you're moving, you have all the values here till 4. So what is my domain here? My domain is between -3 and 4. Now, if I want to see the range is all the values of y. So I need to move vertically like this, from the minus to the positive. From where it starts, what is the minimum value? -2. Is it included? Yes. So it's -2. And I'm moving up. I have all those values of y until the point 3. So the range of this function, and it's included, is 3. So the domain of this function is between -3 and 4, and my range is between -2 and 3. Hope you like the video. Guys, don't forget to like, subscribe, and share, and see you next time in another video.